Hey guys, welcome to the first video on Python thread tutorial for beginners. In this video, I'm going to give you a brief introduction about threads. So first of all, what is a thread? So a thread is an individual and separate unit of execution that is the part of a process. Now what is a process? A process is simply a running program. So for example, if you run a browser, it's a process. If you run a video game, it's a process. Now inside this process, multiple threads can work together to accomplish a common goal. And threads allows the program to run in parallel. That is the single most important benefit of using threads. So let me give you an example. So when you play a video game, it has to handle few tasks. For example, it has to handle the graphics and the user interface. And if you are playing the multiplayer game, it has to handle the networking. And all those things it has to handle in parallel because it has to remain responsive at all the times. So how does this video game handles those parallel tasks? The simple answer is threads. It can assign one thread for graphics, one thread for user interface, and other thread for networking. So by using threads, the video game can always remain responsive and it can run the task in a parallel way. Now let me explain threads using this diagram. So you can see this whole blue box here is a process and the threads exists inside this process. So in this process, you can see three threads. Now inside those threads, you can see there is a code and local variable. So a thread is a lightweight process that exists inside the process. Also, a thread is a sequence of control flow. The difference between the thread and the process is that the thread exists entirely inside the process and share its resources. So let's say inside this gray box we have the global variables. Each thread will be able to share those global variables, and in addition each thread can have its own local variables and its own control flow to work with those local and global variables. Now a single process may have multiple threads of execution, and as I already said that threads are useful when an application wants to perform many concurrent tasks on a shared data. Now let me give you one more example. So think about a browser. It has to handle the landing pages or the animations, or if you want to open multiple website on different tabs and you want to run video in one tab and if you want to do another task in other tab, most of the time the browser always remains responsive and the browser can handle multiple tasks at the same time. So it uses threads to always remain responsive. Now there are two different kinds of threads. One is a kernel thread and other is a user space thread or a user thread. Now kernel threads are the part of operating system, while user space threads are not implemented in kernel. The user space threads can be seen as an extension of function concepts in programming languages. Now each process have at least one thread and that is the main thread. So if you don't even create a thread inside a process, it has at least one thread and that is process itself. Now let's talk about the advantages of using threading. So the first advantage is multi-threaded programs can run faster on computer systems with multiple CPUs because these threads can be truly concurrent on multiple CPU computer systems. The second advantage is the program can remain responsive to input at all the times. This is true both for single and multiple CPU computer systems. Now, the third advantage is threading allows to do something else while a thread is waiting for a IO task or any other task to complete. So it always remains responsive. The next advantage is some programs are easy to express using concurrency, which leads to elegant solution. And as a result, they are easier to maintain and debug. So some programs or some processes are inherently concurrent in nature. And the next advantage is threads of process can share the memory of global variable. So as I have already shown you in the diagram previously, that multiple threads can share the memory of the global variables at the same time. So if a global variable is changed in one thread, this change is valid for all the threads. A thread can have local variables also, as we have seen in the diagram. Now let's talk about some of the issues or challenges you will face while programming threads for a program. The first challenge is the scheduling. So to execute a threaded program, it must rapidly switch between threads. So a program should be able to switch between threads efficiently and conveniently. The second issue or challenge is the resource sharing. So as I told you that multiple threads can share the same memory of the global variables. So since threads share this memory and other resources, it must be careful because operation performed in one thread could cause problem in another thread. The next challenge you could face is of synchronizing of the threads. So threads often need to coordinate their actions, and as a software developer you may have heard about race condition of threads, which means the outcome depends on the order of thread execution. And often for synchronization we use locking primitives. Now that was the general description about threads. Now let's talk about the threads in Python. So in Python, a thread is an object like any other object that can hold data. This object can also be used to run with methods. The object also can be stored in the data structures, and this object can also be passed as a parameters to the methods. Also in Python, a thread can also be executed as a process. And during the lifetime of a thread, it can have various states. Now in Python, there are two modules which supports the usage of threads, and these two modules are thread module and threading module. Now there is one thing to note here is that the thread module has been considered as deprecated for quite a long time. So often users are encouraged to use the threading module instead of the thread module. So if you will see in Python 3, the thread module is directly not available, but indirectly you can use underscore thread to use the thread module, and this is to remain backward compatible with the previous versions of the Python. Now the difference between the thread module and the threading module is that the thread module treats the thread as the function, while the module threading is implemented in an object-oriented way. So in the next videos, I will show you how to use these two modules in Python to create threads and handle threads in Python. So that's it for this video. I will see you in the next video.